Okay, we are recording.
Okay.
So right now, Andrew is going to be asking me his question, and then afterwards I'm gonna ask him my question.
Okay, so your question is, given a binary tree, I want you to return the left view of it, which is the set of nodes visible when you visit the tree from the left side. So I will finish writing here in a second the beginning of the function that I want you to finish, um, which is you're going to return it within a vector. They're going to be, the nodes are going to have an integer data, as you can see in the structure for the node. Um, left view, it's going to be an input of a root node. Uh, and so if you look at the examples, basically for the first one, it follows the left path down, and then same with the second example. The outputs are right below it to give you, give you a quick example of what it is.
So in this case, okay, I just want to make sure. So in the vector, in terms of the order, it starts with A, and then it just goes down the left side of the list and just is basically appending it to or adding it into the vector, each of the nodes into the vector. Is that right?
Yeah. Yeah, so
Okay.
the first one will be the root node, and then you'll be following the left path, adding each new node data onto it.
Now I'm only adding the data of the node to the vector, correct?
Correct.
Okay, not like the nodes themselves. Okay. Um, and then node is data, and then there's left and right is null. Okay. Okay, so I think for my let me also just share my screen because I think like I'm supposed to do that when I here, let me. So I would think for my, the way I would approach this is that obviously I would start at the root. I feel like that's pretty obvious. And then I would make the vector and append or pushback. I would use pushback. Um, and I would probably just literally start at A and then push back to B and then push back to D and add like a um maybe like an if like the current node, if the left of the current node is null, then we know to stop. Um, but if, else just keep on going to the left node. I would think it might need to be recursive. I'm not sure. Um, actually, probably, I don't know if I would do recursion or not. Um, but let me see. Okay, so if I start with, um, let's just make a vector. Ooh, vector int. Why is it capitalizing? Um, nums, and then in. I hope I initialized that right. I haven't initialized a vector in a minute. I actually probably need to. I probably need to add the like include
Don't
vector.
worry about adding the include part. Just assume that anything you want to use is already included. So you don't have to
Okay.
worry about like std or adding the includes for anything.
Okay, cool. All right. Okay, so vector int num. So then, I mean, if that's right,
That is
we'll see.
correct initialization.
Okay.
Initialization, yeah.
Okay. So in this case, what I would do, I would say if should I do root? I'm trying to think if I should do the root. They're taking in the root node. Well, I could do a case if root left equals null pointer, then we could just say, so actually, I have to ask another constraint here. Would
Mhm.
I ever be given a tree that's just empty or
Yes,
like
that is a
just a node?
possibility.
Okay, okay. So that's good that I'm doing this case then because
Yes.
this would account for that. So if root left is a null pointer, then I'm gonna return nums, but it would just be a blank um a blank vector. Um and then I'm trying to see. So if else so we have if it's so else if the root is not null, else um um root left. Okay, so I think the way I could do this, yeah, so I think I could do this recursively. Um and what I would do is like so I'm just trying to like talk through as I do it before I actually go
Mhm.
ahead and like write it. But if it's first checking if the left of the root, it's not a null pointer. So then from that case, it knows, okay, I can go to the left and I can add that to the vector. Um, so well, first and foremost, when you're at a current node, you're gonna have to add that value to the vector. And
Yes.
then you have to check, sorry, then you have to check whether you can go left or not. So from that case, if it was to go left, it would it would check if it can go left, and then I think it would just call the recursive function to go to the so it would call it, but in the parameter, it would just call it root left. So that way it's calling. So let me see if I can like so first I'm just gonna do nums dot pushback um root data. So nums dot pushback root data, obviously putting putting that data there. And
Mhm.
then in this case, it could call, so we know that the next node exists. So there is a left node in this case. So then we're just gonna call left view. Oh God, that was that was my left view of root left. Oop. So in this case, what it's doing is that, yeah, so you have, so first and foremost, it makes, oh, actually, I should probably make the vector of nums outside of if I'm going to be doing it recursively, just because I don't want to make a new vector every single time I call it. Um, so I mean, if this was in like a main or something, I could make it globally, I would say, or just outside of that class in general. But when I do make this, um, yeah, so this is gonna go through here, and then after it needs to return, obviously. So, but I'll get there in a second. So, yeah, you take in, you're pushing back originally the root because we know that the root at least is gonna exist, right? Or is the root okay? So we're gonna be given at least a root, but then there can be other things, or could it be empty?
It could be empty. So
Oh,
the
okay,
the node root that you're getting could be a just a null pointer to start with.
okay, okay. So if yeah, so let's actually add that if root equals null pointer, um, then we're just gonna return nubs because it still needs to return a vector, but it's just gonna return a blank vector. Um,
Mhm.
so yeah, that's the first case, and then if obviously we know that it's not a null pointer, then we know that it has some data. So we're just going to add, this is adding the data into the vector. And then in this case, we're checking if the left exists. If the left exists, um, wait, why am I returning? If root left, oh, okay. So yeah, if root left is a null pointer, we know that we've reached the end of the tree. So then we just return nums. Else, if that's not true, then we
I
know
will
that the
say
left.
quickly, just because the left root is a null pointer doesn't necessarily mean it's the end of the view. If you go back up real quick and you look at the second example,
Oh, so it can go to the left, but then it might. You also need to check. You need to check left and right. It just needs to be that
it
the
needs to follow the
first.
leftmost path all the way to the bottom. Yeah.
Oh, okay. So in this case, we could check if it's a null pointer. So if the left is a null pointer, um, we know that okay, we can't go to the left anymore, but we still have to check if we can go to the right because you can still. So I could just add if root left equals null pointer return. So I wouldn't return nums. I would say I could put another if statement inside of here. I could say if root left is null pointer. Actually, let me do. I could do an and. Uh, I'm trying to think if I should link them together, like if root left is null pointer and root right is null pointer, then we're gonna return because then we know we've reached the end. Or if I could do if yeah, so if root left is null pointer, if root right um null pointer. So in this case, we know okay, um this is the end of the tree. So then we return nums. Why does it keep okay? I hate Google Docs. Okay,
From now
and
on,
then
don't worry about correcting the capitalizations because it's just going to keep happening.
yeah, okay. We'll just yes, I guess it's just logic is the main
Yeah.
concern here. Okay, so yeah, so it would if both of them in this case, this means both of them are, but um let's say that the right does exist in this case. Um, so if root right is no pointer, then do this. But if we evaluate this to be true and then this is false, then we get to this, which is where we have to do root right. So then we do um, root, or actually we could call it on root right. So we could say left view of root right. So, okay, I'm just trying to review this to make sure that. So we start with, okay, root is a null pointer, return that. Else we're pushing back the data of the root. Then we're checking is the left a null pointer. So if the left isn't a null pointer, then we immediately jump down to the recursive call for this, um, which is on the yeah, which is on the left root, the left node. If let's say root left is a null pointer, then when you look at root right, if root right is a null pointer, then we just return the vector. But if root right is not, or if root right is still, exists, but left is gone, then we have to go to the right. So that's when we call it for the root to the right. I think I think that's pretty much the gist of how I would do it. Um, I don't know if you see any glaring issues like with it right now.
The one issue I can see right now, or the main issue at least, is when you are calling left view recursively, it's not actually like adding the numbers to the vector anywhere.
Well, wouldn't it be right here? Nums dot pushback root
Oh,
data.
I must have missed that. Sorry.
because that, yeah, that's the whole idea is like
Actually,
it
yes.
checks if it's, yeah, because I mean, honestly, this first check here is really only for like the first, it's only
Mm,
really going to work in the first case because after that, like you're already checking if it's going to be a null pointer here for like when you're, when you're putting it into there. So you don't, I mean, that's kind of just like a first base case check. And then this pushback is kind of, yeah, that's like the whole idea is like it goes to that one and then it further checks other nodes after it adds that one.
yes, with that it looks pretty good. Um so yeah, obviously you did this a recursive way.
Yeah.
There are obviously ways where you could use like a while statement instead. Um
Yeah, while how would that, so that would be more like while root left is not no pointer or something like that. Continue to do it, I would think. Like continue to run through it, trying to think of all like different ways to solve it.
yeah, so why don't since you did that fairly quickly, um why don't you try and do it using while instead of recursive real quick? See
Okay,
if you can do that.
let me see. Um, let me. I'm just gonna copy like the entire because I don't want to like remove that. I'm just gonna put
Yeah,
it below and just try to do it.
below. Okay.
So yeah, let me. So obviously, I'm gonna get rid of like all this. Um,
Mm,
the only thing. Okay, so I would think if I'm doing it with a while loop, I would probably keep the same check at the start here. If root is a null pointer, then we're just returning the blank vector. Excuse me. So yeah, so this. Okay. Else, so if it's not a null pointer, um, I would think you could do a while loop and you could say while um root actually, well, if root's not a null pointer, then we have to do root um or nums dot push back of um root data. So that's still like the same idea for the first case, like just going through that. So
yeah.
while root left is not equal to a null pointer. So while the root isn't a null pointer, we're gonna we're gonna say um hmm. I feel like it's harder to think about it not recursively because I don't want to like just keep doing root dot left dot left dot left like every single time. Um,
Mm.
but I'm thinking of, let's see. So while root left is not, so we know in this case, okay, we can at least go to the left of that. Hmm. I think, hmm. I'm trying to think if I should make like a temp variable to store like maybe the left or something just to keep track. Because like if I'm not calling it recursively, I'm trying to think how I could get, because the while loop like it'll keep running, but then how do my one concern is changing the root, I think changing what the root is going to be without doing it recursively seems like weird to me.
Well,
um
so how is one way you could what is like one of the main ways you could keep track of something that'd be changing like that?
I would think a temp variable of some sort. um where you could like maybe store like let's see. So while root temp equals root, I do temp equals root left, or should I do temp equals root? Temp equals root left, probably. Hmm. And then, so we know, okay, so we know we're at a current node, and we know that to the left of that current node is not exists and is not a null pointer. So we're gonna set a temp value to that left node, and then trying to think what I could do. Um, pushback. I'm trying to think if I should do, yeah, nums dot pushback. Um, of temp data. The one thing is though, is like I'm just not sure how it would continue to go throughout the list. Because you start at the root, you know that the left is okay, and then you set temp equal to the left node, and then you get the date, you push back the data from that temp. But
Mhm.
then I'm trying to think how I could get, because it needs to continue to do that. Um,
If you would like a hint, I have some I could give you if you would like a hint.
um, yeah, I'll take a hint.
So the way when I was looking at this, the way I initially did it to avoid the problem you're looking at is that temp variable. I created it before, and where you have the while, instead of having the root left equals null doesn't equal null pointer, I had the temp variable left does not equal null pointer.
Okay.
And so
Huh.
basically at the very beginning I created the temp variable to equal the root and then just use the temp from then on.
So, okay, so up here, you said root left equals temp. Is that
I,
right?
I set temp equal to the base root, not to the left, to the base root.
Oh, so temp, so you made like a copy of the base root,
Mm-hmm.
and then from there in here you were checking while temp left is not null pointer, and then, huh. Okay, that makes sense. So then inside the while loop, so would you make it like temp, or you'd make it temp equals root left, and then you'd shift it to the left and keep going, or how? I'm just thinking how like, because like if you're making just a copy of the root node for temp,
Mm-hmm.
like if temp's just a copy, how is how is temp uh like how would this be different?
Okay, here, let me switch over to the document real quick. And I'll do a little um show right below. So if I'll write mine in black so it's different. So where you have so as you were saying, right up here, I would have a node temp equal to root, right?
Yeah.
And then when I got to the while loop where you were at, it would be a while temp uh, left does not equal null pointer. And then after the while, in order to keep it going, um, it would be temp is equivalent to the new temp left. So that way, once you
Oh,
got the left variable, you're now focused on that one again. And so this would
okay.
essentially change what you're looking at as the root to be the new left.
And then since it's modifying temp inside of the while loop, it's okay, that makes sense. So it's basically inside. So here it's changing it, and then when it comes back up to the top of the while loop up here again, it's gonna say, okay, now we're not looking at, even because we're setting temp equal to temp left, it's gonna say,
Mm.
okay, now is temp left's left, is that
Yeah,
gonna be a null pointer? And it just keeps, okay, that makes
and then it
sense.
keeps going.
Yeah, okay, that's an interesting solution. I mean, I think I'm just used to recursion because, like, especially for the AVL tree project, a lot of the functions, like, we used recursion to, like, traverse the tree and stuff, um but this, yeah, the while loop, I mean, that makes sense too. Um but yeah, I mean, I don't know. I think I'm more comfortable with recursion just for trees in general.
That's
Um
fair. Like I said, you
but
did very well with your attempt using the recursion. So it was just a little test to see how you would do
handle
if
it
you
and
weren't able to use the recursion.
recursion, yeah.
So
Yeah.
I don't think you need to continue anymore. I think you did pretty well.
Okay.
With the rest of that, it's very similar to what you did, which is just you have to check the left, and if the left is open, you add it, and then you change it there. If it's not open but the right is open, you
Check the
change it,
right.
you take it to the right, and you add it.
Yeah.
So it's very similar. It's just slightly different wording. But as I said, you did very well when doing it with recursion, your preferred way, which
Yeah.
was good. Give me one sec. The one of the bigger things like I said, you did very well with yours. The one thing I would say you could improve on, um, is take just a little bit more time analyzing the different examples, because when you originally started, you were
I
only
didn't know
looking at
about
the
the
left
right.
group. Yeah,
Yeah.
you
Yeah.
kind of missed out that part. Other than that, I think you did very well. You explained what you were doing quite well. I was able to follow it pretty well. So good job.
Thank you.
Um,
All right. Are you ready
yeah.
to transition?
Yes, I am.
All right. Let me go up to mine and I'm gonna like read, let me see. Am I sharing? I'm gonna kind of I'm gonna also give you the link for the leak code, even though like we're not doing it in there, just so you could, because there's pictures and like a little
Oh, okay, okay.
description and stuff, so it's just easier to like kind of get an idea. Let me know if you can see it.
Uh, Pulling it up now. Okay, yes, I can see it.
Okay. Um, okay, yeah. So basically what this problem is you're given, yeah, the head of a linked list. It's a single linked list, and your goal is to basically reverse the linked list. Um, Obviously, like, you can't traverse, you only can traverse forward through a linked list.
Mm-hmm.
Um, and yeah, your job is to basically, like in this example, it has 1, 2, 3, 4, 5, and it changes it into 5, 4, 3, 2, 1. Um, and it also gives you like a little structure for the list node, which it has the value, the next, and I think these are more like constructors, but um, yeah, basically your goal is to reverse the linked list.
Mm-hmm.
Um, and let me know if you have any other questions about any specific, you know, details.
Okay, and then I'm assuming I'm not allowed to use like another data structure. Like I can't just add it all to a vector and then.
No, you can do anything. You can do anything that you think would work. That was originally, it's funny you say that. That was originally one of my thoughts, was to like add it to a vector and then kind of like traverse the vector backwards.
Mm,
The only problem is that you don't know how big the linked list is. So I mean, you could do a vector because I guess you could add it to a vector and then
mm-hmm.
reverse it. Um, but yeah, I mean, whatever you think is your most comfortable way to solve the problem. And I know they said in our discussion, they were saying like when you're in one of these, when you're just trying to solve it for the first time, like do whatever is most comfortable and then worry about optimizing later. So it doesn't need to be the most optimal solution, just something that works.
Okay. Let me just take a look and read this a couple times
Yeah,
first.
read it over, think about it.
Okay. Um, will I be? Is it possible to be given a list with no nodes, or well,
So
an empty list?
yeah, so example three has, I'm pretty sure yes, because example three has input head is just a blank
Oh, okay, I
and then
see.
output is blank. So yeah, I would think you would need to add in some sort of case to account for that.
I did not see the example three. Okay. Okay, and so it's in. Okay, so I take in the head. Okay. Okay, so yeah, my first thought is to basically traverse through um the traverse through the list and put it into another container, preferably vector for me. That's my most comfortable container, and then just go backwards through that container. Um,
Yeah. And a
and
vector would probably make the most sense just because it's not, you don't have to define it with a set size. You can just continue to add to it.
yeah. So what I would here let me do this real quick. I'm gonna write it in red so I can keep the difference between what was I was started with and what I wrote. Okay, so I would probably start with creating a vector. Do I know? Let's see. Okay, so it's integer values.
Yes.
Okay. Um, to nums, and so I would probably. Oh, I would probably do a while loop, and I would because I have to in I'd have to go through it until the next value is a null pointer.
Yes.
Actually, before I do this, um, I have to I'll do it right here, and I'll do a if head is a null pointer. I'm just gonna do that here. If the head is a null pointer, then uh, it's not going to change anything. So I just return the head. Because if it's a null pointer, um, reversing it would still just be the general null pointer, and I have to return the head of the list node. So,
That makes sense.
um, other than that, yeah, I'd probably. So if that's like that, then I would do else. I would do a while. Actually, uh, I'm actually gonna create a temporary node as well, if that's okay. So I'll do because I really like doing temp nodes just to keep the original one how it is. And put that to head. And so for this while loop, I would do while head does not equal null pointer. Um, let's see. Let me look at the examples again. lost the page. Okay. Okay, so yeah. So yeah, I would do while the head is not a null pointer. I would do or no, sorry. Nums dot push, if I type push back, and then I would do head value, and then I would do or ooh, let me fix this. Not head, but my temp variable, and same here. And then I would do temp equals temp next. And so what that'll do is that'll add it and then go to the next node. And it'll go all the way until temp is no pointer, in which case it won't run this, so I won't have a error with this because it'll stop before then. And then once it's like that, I could let's see. Oh, okay, right here. This is this node. After that, I could probably create a new list node. Call new list node, and let's see, what would I do? Probably just with the value of the current vector. So hold on. So I would do vec. Oh, wait. How do you do it again? Oh, what is it? Pop back? I think it's pop back. Vector pop back, which I think returns the last value in the vector. Pop back, and then deletes it. And so that'll create the new list node. Ooh. Wait a second.
So in this case here, talk through like what explain exactly what would happen if the code is running through your while loop. I think that usually helps me at least.
Okay, so while it's running through the while loop, which is as long as the temp variable isn't the null pointer, so it'll run through all the variables, and when it's at the last variable, the next will be null, and so it'll make temp null, and then it'll stop after that. So it'll run through all the nodes in it,
And
and
it's adding those to the vector.
in each one, it's gonna add the ooh. Do I need
We have pushback, nums.pushback temp val.
Yeah, that's adding the value. Should I add the value or the node? Probably
Um,
probably
no,
the
I mean
value.
the values should be fine because you're only trying to reverse the values. You don't really and as long as you're going through the nodes, you know,
Yeah.
in order, um, yeah, you should be fine. So okay, so you have and then what's the pop back? Your
I believe, let me double check, but I'm pretty sure the pop back gets the last value of a vector and then deletes it, if
So
I'm
you're
correct.
deleting, why are you deleting the last value of the vector?
To reverse it. So what I was doing here is, let me go down here real quick. Is let's say I have 5, 4, 3, 2, 1. I'll space it out. Right, that's my vector.
Yeah.
I'm gonna create a new list node, and what I'm gonna do is I'm gonna take this last value, delete it out of here, and add it here. But
Okay.
that's, oh, that'd be in a different while loop though, wouldn't it?
I mean, I don't know if you need to necessarily delete the last one. I would just traverse through the vector backwards and just make a like
I
because you
could
have them
do
in
that.
order.
Yeah.
And you know you can get vector dot size, I think it is, to get the
Yeah.
so you could
So I could
traverse.
probably do while, or I keep going vector. Also I
Ye-
messed up here. This is nums. So while, or sorry, not while. Uh, for equals 0. I is less than nums dot size. Actually, no, I'll do it this way. This way is easier. Equal to nums dot size minus 1. And then while I is greater than or equal to 0, um, I minus minus. Looks like, there you go. Wait, I minus minus. Um, where I'm finding my issue is creating this list. Hold on, let me relook.
Creating the list is definitely like because in this case you're gonna have to make a new
A new
um
temp variable.
yeah, and to clarify, obviously, like you're returning the head of the reversed list. So like if it was 5 4 3 2, if you were given 5 4 3 2 1, you would be returning one because one would be the new head of your
Yeah,
reversed
yeah, yeah.
list. Yeah. I just wanted to
Okay,
clarify that.
I know what to, I know how to fix my. All right, so I'm gonna take where I create this new node, like the new node, and I'm gonna put it out here,
Okay.
right before the for loop, outside of the while loop, right? And so that'll give me my head node essentially. And then I'm gonna do another temp node. I'll just call it cur. Or let me do list node cur, which will equal my new head node. And I can do in here, which I can do cur next equals new list node of value, which would be nums I. And then here I could do cur next. Or sorry, cur equals cur next. And then all the way at the end here, I would do return. Fine, let's just put that there for now. So let's see. Int I equals num size minus 1. That way it's not out of bounds. Goes all the way, including 0. So it gets all of them. Goes down by 1. So actually, uh, let's change.
I would think you would just need it to be list node Like it would just be the end of it, nums dot size.
Nums. Oh, what's wrong? Nums dot size minus one, technically. Um, okay, so this will get the first one, right?
Yeah. Well,
This
the
well, the
final.
last digit of the vector.
Yeah.
So I need this to be minus two, because otherwise I'll duplicate the last one of the vector.
Okay.
So we'll pull these back up here. So 5, 5, 4, 3, 2, 1. And I need to get to 1, 2, 3, 4, 5. So this will take 1 and put it in final. So the value of final will be 1. That would mean the current, no, the current's good where it is. The current creates in the next node with a value of 4, or of 2, sorry. And then it goes to the next I minus 1, then it goes 3, 4, 5. I think that works, right?
And so you have your current value in this case is 1, and then current next is so you're making a new list node object, oh, at nums I, which would be here,
Mm-hmm.
and then you're going back current equals current dot next, and then return final. So then you're returning in this case, oh, because you're returning 1.
Yeah,
Okay.
I'm returning
And
the 1.
but you're setting the next to, so 1 dot next is 2, and then yeah,
Mm-hmm.
that makes sense. Okay. I mean, that seems like it would work.
I don't think it's the most efficient. There are
Oh,
definitely things I could
yeah.
have made more efficient in here, but
I don't blame you there. When I first looked at it, I was thinking about doing a vector like that. And that definitely like makes sense here. Let me show you what I ended up having.
okay.
Um so let me see if I can just actually I don't know if I wanna, can you see my screen?
Yes, I can.
Okay, I'll just show you on here because I don't need to copy it onto the document and we gotta delete
Yeah.
it and everything. So
Okay.
basically, this is already here. So what I had is a while loop um, that basically starts at your head, and while it's not a no pointer, you're continuously running through it. So
Mm-hmm.
it's very hard for me to like. I drew this out, like I had it all, like I had like a paper and I was like drawing out, like making sure that this would work.
Yeah.
But basically, it's gonna set your next, because your next in this case is a no pointer, so it's just going to set the next to the next of the head. So in this case, like you would have 1 would be your current, 2 would be your next, and then
Mm-hmm.
it would say, okay, the next of your current, so the next of your 1 is now, instead of being 2, is going to be your previous, which is just going to be some no pointer. So then it takes the no pointer and it's just pointing to it out here, and then like your previous node, which was originally a no pointer, is now going to be 1, because it's so hard for me to explain without drawing it out. It sounds, but I promise it works. And then your current um your current value is just going to be set to 2, so it's going to originally set the next to 2, then it's going to take 1 and it's going to point to, one's going to point to some null pointer, then the null pointer is going to be 1, and then your 2 is going to be your current. So it's basically like the way it's working is that it's basically reversing the order of which the next pointer points, if
Yeah.
that makes any sense.
Mm-hmm.
Um and that way it only has to go through the list once. It doesn't have to go through it and then do some modifications. It just goes through
Yeah.
the list once, and modifies each of the next pointers as it goes along. Um, which I mean it works, and it's a pretty clean solution. But it's definitely like hard to wrap your head around unless like you draw it out. Like drawing,
Yeah.
that's the one thing with linked lists, and that's definitely something I would recommend um in general for you like working on any sort of problem with trees. Or I mean even myself, like when I was working on that tree problem, I could probably do some more drawing out because drawing is so underrated.
Hmm.
Like if you draw and you talk your way through it, I know everybody has like their rubber duckies when they're coding, but it's definitely like a great tool, a great um just way to organize your thoughts is to just, write it out, give yourself a few examples. And you were kind of doing it with this.
Mm.
Um but it really, yeah, that really goes a long way when you're trying to solve a problem like one of these. Um
Yeah.
but I mean, your solution seems to work, and I would assume it works. So great job. Um, and Yeah, I mean, I think it was that vector solution is definitely the first way I would think of it. Um, and it's definitely a more like comfortable way to do it because it like this solution was more optimized and more like like going through it once is very efficient, but it's also like a lot harder to wrap your head around. So,
Yeah.
but um okay, before we close it off, I want to just make sure that we kind of organize the document a little bit
Okay.
and just make sure. So this is um
I would just write like interviewer and then one who's ever was the interviewer for it and then interviewee.
yeah, interviewer Andrew. Okay. And then I should probably make this black that way.
Yeah, I would separate the colors of the code.
Yeah, so this will be black, and then this is red. This is black, and then um, this is the second. Oh wait, is this? Oh wait a minute. This is black, I think. This is
Uh,
a whole nother. This is the second solution.
yeah, I would put the second solution on like the next page.
Okay, yeah, let me through that. Second solution, and I'll just like put like unfinished.
Yeah, yeah, yeah.
Okay, and then kind of, and then this is. Oh, this was what you wrote. Okay, I'll just get rid of that. Okay, so that, and then this is. Okay, yeah, so this is my what I did, and then okay, cool, cool, cool. Okay, all right. So let me okay.
Okay.
All right, so this is shared with you. Are you able to just submit this, or I guess you could make a copy and then submit it?
Yeah, I'll find a way.
Okay, and then we have this. I'll email you the copy of this recording if you don't
Okay.
get it. I don't know if it'll either give it to me or you, and then you could submit that as well. And then we should be all set. I think there's just um like a survey at the end, and that should be
Yeah.
it. Okay.
As for the recording, I don't actually know if we can straight up submit the recording. I think you have to like post it on YouTube or something. I think they were saying something about that.
Oh, we might have to.
Um,
Where is
yeah,
it?
you cannot upload the video on Canvas. You can upload the video on YouTube using unlisted setting.
Okay. Use an unlisted setting.
Using unlisted setting.
Hmm.
Upload it on Drive or Dropbox.
How do I don't even know how to stop. Oh, pause/stop recording. Okay. I'm gonna stop.